Hey everybody, welcome back, and today we're going to start section 2 of chapter 2 on circles. And so we're going to talk about the center radius form of a circle, the general form, and then of course an application problem. So the definition of a circle is a set of all points in a plane that lie at a given distance from a given point. So, or in other words, a circle is the set of all points in a plane that are equidistant from a particular point. Okay, so the given distance is the radius of the circle, and the given point is the center. So the general form, or the radius center form of the equation of circle is always given by this. Okay, now H and K represent the center of the circle, where R is the radius. And X, Y represents some point on the circle. Okay, so X, Y is any point on the circle. HK represents the center of the circle, and R is the radius. So the most general form, right, the center radius form, is going to be of this form. Okay. Now, if the circle is centered at the origin, then H and K are both 0, and it reduces to this simple equation. Okay. So if it looks like this, then it's always centered at the origin. But if it's in this form, then it's going to be centered at what these are. And pay attention that these are all both subtraction. Okay. So that's going to be important. So just remember that those are both subtraction. Now here it says find the center radius form of the equation of each circle described. So here we go. So they give us the center of -3, 4, and a radius of 6. Okay. So now we're going to use so this is H, and this is K, and this is R. And so we're going to basically say X minus -3, which is the same as X plus 3. And then we're going to have y minus k, which is 4, so y minus 4, right? So those are going to be both squared, right? So notice that, oh, by the way, notice that this is very similar to the Pythagorean theorem, okay? Right? A squared plus b squared equals c squared, okay? Okay, so now here's the general form. So all we're going to do is plug in our values, h, k, and r. And we're done. So watch the sign. So again, this is going to become a plus, right? And we're done. And then we would basically simplify, right? And so this is all we do. Now what about this one? Here's the center is at the origin, and the radius is 3. So this is going to be x squared plus y squared equals what? 9. And we're done. Now given the form, what is the circle? And how do we graph it? Well, here, notice that this is 3 and this is 4, right? But notice this is a plus sign. So remember, this has to be in the form where this is both subtraction. So this would be a minus a -3. So h is -3 and k is 4. So the center is located at -3, 4. Be very careful. Students make mistakes when it comes to there's a plus sign here. Okay? If there's a plus sign here, you have to change this to a subtraction and then change the sign of this number. So this would be a minus -3. Okay, so h is -3, k is +4. So -3, 4 is the center. And what's this? What is the square root of this? 6. So r is 6. And so now once we know the center and the radius, we're done. We can easily sketch the graph. And the way you would do this is, and the way I would do this is, once you know where the center is, just go what? go 6 units this way, go 6 units this way, go 6 units to the right, and go 6 units down, and plot a point at all 4 of those, and then just do a smooth curve as best you can. Now what's this one? Now notice where this one is. So where's this one centered? Well, it's centered at 0, 0, right? And what's the radius? The radius is going to be 3. And so there you go. Okay, now the general form of the equation of a circle is given by this form. Okay, now notice that it's x squared plus y squared, and then it's got these two x and y terms, and then it's got a constant term. Okay, so it's always of this form. This is the general form of a circle. Okay, so if you see something that has an x squared term, y squared term, an x and a y term, and then the constant, then chances are you've got a circle here. Okay, and again, notice that these are all plus signs, okay, in the general form. Okay, now it can have a graph that is a circle or a point or is non-existent. Okay, so it may not be a circle. Okay, so let's consider this form. Okay, there are 3 possibilities for the graph based on the value of c. Remember, this is the radius. So what could c be? C could be what? It could be positive, right? So if c is positive, then r squared equals c. And so then we can find r by taking the square root of c. Or c could equal 0, which means we don't have a circle but a point, and it's just the single point at HK, the center of the circle, in, well, quote unquote circle. Okay? Or the radius, or c, could be negative, and in this case, then there are no points that would satisfy the equation. So those are the 3 cases, right? So if it's greater than 0, we have a circle with a radius. If c is 0, then we have a point, which is basically just the center of the, just HK. And then if it's negative, well, then we don't have any solutions. We don't have a circle at all. Okay, now let's, given this form, this general form here, let's show that this has a circle as a graph, and then find the center and the radius. Okay, well, how do we do this? Well, guess what? We're going to solve this and put it into the center radius form. Okay, so we're going to complete the square twice. What we're going to do is we're going to group these x's here, right? So we're going to do the completing the square on this part, and we're going to do completing the square on this part, and then we're going to see what happens to the constant here, because again, remember, when you complete the square, you end up with extra constants, and then we'll see what happens. Okay, so let's go. So here's our graph, or here's our general form. And so now what are we going to do? We need to find what the completing the square here is. So we're going to divide this by 2 and square it. So that's going to give us what? A negative 3 squared, which is 9. So we're going to get a 9 here, which means we're going to have to add 9 over here, right? So they move this over to the other side, just like we do with completing the square. And so here we have to add 9. So we're going to have to add 9 over on this side. And here we're going to have to add 25, right? Because 10 divided by 2 is 5, and 5 squared is 25. So we're going to have to add 25. So we're going to have to add 25 and 9 on this side. Well, what do we get? Okay, well, there's our 2 numbers. Okay. And so what do we get? We get this, because now this becomes x minus 3 quantity squared, And this becomes y minus 5 quantity squared. And now we've got it in the radius center form. And so this is h, right, which is 3. K, what is k? Is it 5 or negative 5? It's going to be negative 5 because this should be a minus. So to change this to a subtraction, we're going to make this into a subtract negative 5. Okay, so then this is good. So the center is going to be 3 comma negative 5. And the radius is what? 4. Okay. Now, show that this here, this expression, has a circle as its graph. Find the center and the radius. So now let's do the exact same thing. We're going to group the x values together, and we're going to group not the x values, but we're going to group the x terms together, and we're going to group the y terms together, and then we're going to do the completing the square twice again. Okay? Okay. So now, remember, when we do that, keep in mind that the leading coefficients must be 1. So we can divide this whole thing by 2 if you want. So here's what we start with. And so we divide everything by 2 and we get this. Okay? And so now we're going to group these terms together just like so. And now we're going to complete the square. So this is going to give us what? 3 halves squared, which is going to be 9/4. This is going to give us 5 halves squared, which is going to give us 25/4. And then so we're going to add those over on this side as well. And so now here's what we have, right? So we've got this one and we've got this one. And now we're going to simplify this over here. And so what are we going to get? This is going to end up being x minus what? X minus 3 halves, quantity squared. This is going to end up being y plus what? Y plus 5 halves, quantity squared. And then whatever this reduces to, which is going to end up being what? It's going to end up being 36/4. 36/4, which is the same thing as 18 halves, which is the same thing as 9. Okay? And so now the center of the circle is located at 3 halves, comma, negative 5 halves, and the radius is 3. And there you go. The graph of this is either a point or is non-existent. Okay? Which is it? Well, let's find out. Let's find out. We're going to have to do the same thing. And we're going to have to look at whatever the constant is over here when we're done. So right now, we really can't tell until we do the completing the square and we find out what the final value is going to be. Okay, so here we're going to subtract 33 again because we want the constant over on the side. And now we're going to group the y values, right? And the x, or the y terms and the x terms. And so now what happens? Well, to complete the square, this is going to be 25 and this is going to be 4. So this adds up to what? 29. Well, then we have to add 29 to negative 33, and that still gives us a negative number. And therefore, since this turns out to be a negative number, this is not a circle at all. It's non-existent. Okay. If this turned out to be 0, then we would just have a point located at -5, 2. But since it's negative, there's no ordered pair xy that will make this true. So this is non-existent. Okay, so now, what if we want to locate the epicenter of an earthquake? It says, suppose receiving stations A, B, and C are located on a coordinate plane at the points 1, 4, 1, 4, -3, -1, and 5, 2. Let the distances from the earthquake epicenter of these stations be 2 units, 5 units, and 4 units respectively. Okay, so we've got the location of these three receiving centers, and we're going to say that the corresponding distances from each one of these stations is given by 2 units, 5 units, and 4 units respectively. So this point is 2 units from the epicenter, this point is 5 units from the epicenter, and this point is 4 units from the epicenter. Where on the coordinate plane is the epicenter located? Okay. So, what does this mean? Well, if we're talking about epicenter, okay, and we know these distances from the epicenter, we can use this to find, you can use the information to find where it is located. Okay, so what we're going to do is we're going to graph the 3 circles. Okay, because this is going to be a point on a circle that has a radius of 2. This point is going to be, we're going to use a circle of this point on a circle that has a radius of 5. And then this is going to be a point on a circle that has a radius of 4. Okay. From the graph, it appears that the epicenter is located at 1, 2. To check this algebraically, okay, we're going to determine the equation for each circle by substituting x equals 1 and y equals -2. Okay, so we're going to graph the 3 circles, right? By graphing those 3 circles, we know that they're all going to intersect right at the epicenter. Okay, because what we're doing is we're finding that, hey, this station is what? 2 units from the epicenter, but we don't know where. It could be anywhere around here, right? But we don't know. And then we have another one here that's what? C is 5 units, or no, not 5 units. Is it 4 units? 4 units. So it could be 4 units anywhere on this circle, right? We just don't know. And so here is going to be 5 units. Yeah, 5 units. So it's going to be anywhere on this circle. So all they told us was the distance from the receiving station to the epicenter. So this is called triangulation. Okay, so wherever these circles intersect, that's it. That's the epicenter. So it appears from the graph that it is going to be 1, 2. But how do we show this algebraically? Okay, we're going to determine the equation for each circle and then substitute 1, 1 and 2 and see if they satisfy all 3 equations. Okay, so solution A, so here's what we get, right? So here's x minus 1, so this is for this one, 1, and y minus 4 quantity squared equals 4. So there should be a parenthesis here. So if we solve this, do we get 4 equals 4? Yes, we do. So it checks. Now what about B? we're going to do the same thing. We're going to take this form of the equation, right? So this is the center that was given, and the radius is 5, so we get 5 squared, which is 25. And now we're going to plug in 1 and 2 again. And we're going to see if we get 25 equals 25. And sure enough, we do. And finally, with the last one, we're going to see if we plug in the values and we get 16. And sure enough, we do. So we just verified algebraically that the epicenter is indeed located at 1, 2. And there you go. And there you go. That is the end of this section. And again, make sure you're practicing this stuff. Okay, go over some suggested homework problems on your own. Do some of the other examples in the textbook, and or some of the exercises at the end of the book. And if you get stuck, hey, that's what we're going to be doing in class. So make sure you email me if you want me to go over a particular problem or help you. Or wait until class and ask me in class, and I'll be more than happy to help you. Okay. So again, until then, have a great day, and I'll talk to you soon. Bye-bye. Circle.